Alright, welcome back everybody. We're going to continue this session on building up the chromograph project. Might start here. This is the Archinect article in chromograph, which is CHROMA graph, chromograph. So this one had a little bit of help in a diagram. It's a little more expressive on how they went about it. We started looking at this a little bit at the end of last class, but one of the points that I noticed in looking at this, because they did some sort of rationale in terms of how they developed the curves, but in the end what they did was mirror it. We were creating two sets of curves and having some challenges last time, so we'll go ahead and we'll start this session by modifying where we left off, mirroring these and doing some work there toward rationalizing the model to fabrication. So if you want to start, let's open up a file I put in the project server, and it'll be chromograph file and chromograph. And this is where I left off. You guys were at something similar. So what we'll do is we'll go ahead and we'll do that mirroring operation, and then we'll go ahead and do some work to review what we went to and move forward a little bit. We'll do some cleaning up. Alright, so if you remember at the very beginning of both of these, because we did a section of data that was from here to here, that was kind of 1/2. We copied that whole bit to the second half, so identical geometry across here. And actually, at the very end, I imported the second set of curves, as your file will have as well. So we need to basically replace this bit of move with the mirror. So if you remember right, there are 3 curves that are selected. Then based on this guy, they're moved up in space, and the loft is generated between them. So we just want to remove this set of independent curves and just go with a mirror of the first 3 we did. Alright, so mirror is found under the transform tab, Euclidean mirror, or you can type it in. 2 inputs, takes geometry to mirror, and a base plane. In this case, we want to mirror it along the x-axis. So if I look down here at my compass, the plane that matches up with what I want to mirror is the xz plane. You can just type that in, xz. This is the xz plane at the origin, which you can see there. So that looks right. So I'll go ahead and do that. Now, these are my 3 curves. They've already been moved up. So that's the last operation I did right before we lofted the surface. So those are the 3 curves I want to do. If I had done anything further back, you'd have to do a repeat of these move operations. Since we want them to be the same, we'll just move this, or mirror this. So there's my mirrored, there's my original, and these ones I'm going to replace into the second loft, like so. Now I'm just going to go ahead and delete that bit there. And now this actually should work and look a lot better than it did previously. Go ahead and turn off preview mode. You can see that looks a lot more like the start of the actual chromograph. One thing you'll also notice is that in the way that we did the data, we have these set of curves, but then we have one set of the intermediate pencil elements passing forward. We'll come back and address that later. So in the actual solution, when you look at it, you have kind of a starter vertical element and a finisher. And if you count them, you'll have one bay larger, or one quantity larger than the spaces in between. Just like, we'll come back and we'll take a look at that a little more in depth later. So what I'm going to do is go through this a little bit and clean this up as a review. You can do that as well. I'm going to save a second version of this called Chromograph 2. That'll be the cleaned up version with labels. So you can watch and follow along, just a little bit of a review session of what we did last time, and then pick up with that as well if you want. Okay, so just a quick review. So we drew the three curves we have here, spaced them a little bit, so and selected them so that the loft went in and out. So that is the first element here, is selecting those three curves that I drew in Rhino. I made a series with 3 values in order to move those up in space. And in this case, we actually started the first value as a negative number. If you look at the answers, I had -12, 48, 108. The -12 was so that when we trimmed it, no matter which direction we offset it, we still had this nice flush trim with the floor. Since it started off it started off below the floor, so it's definitely, when you cut it, it will be flush at every unit. So the first few here we deal with are the base curves. So go ahead and label these. So this is the curves and then the resulting loft. As you can see, that's the surface there. Alright. I'm also going to pull out here some of the things that are important to the numerical adjustment of this, and label those as we go. So this series has a few items that are important. We'll leave 3. 3 will be kind of this static, but this one we'll call half height. That was that 60-inch value. And I'm going to make this guy hidden. Oops. Wire display hidden. I guess I have to do it here on the receiver. There we go. We'll pull all these apart and we'll put them up separate so we can change everything together. This next section here, if you look, is giving us the final surfaces that we use to make our intersects that then we generate the fin geometry with. So all 3 of them together, you have an outside, an inside, and a middle. Middle we use to start laying out the points on the curve in order to add our pencil locations. So I'm going to go ahead and label all of this. If you look at what we do, so you take the loft, there's an offset, there's 2 offsets. These are B rep by plane, so these are intersecting a couple different planes. One of them was the XY plane, so that's a ground level. So these 2 are surface splits, so they are splitting the surface by curve. So in this case, we have our offset, we intersect it with a plane to get a curve, and then we take that same surface and we split it by that same curve. If you look at the results, it gives you all of the surfaces, so you have basically the piece below ground level and the piece above it, and then we do an item select. Just happens to be that in this case, selecting the 0 item, or the first item, gives us all the top ones. So this one, this midpoint section, we decided that we weren't going to do the pencils all the way from the ground. Those actually started a little bit above ground. They look like they started basically on a level line. So we did a point, these are 0, 0, and then we moved it up Z. So that is the height, and then that got fed into the plane. So this plane starts a little bit above ground level. We said 9 inches, and that's where we split that surface. So it starts a little bit higher. It is a reference surface. It's not going to be used to create geometry for the fins, so it actually needs to start up a little higher. Okay, so let me take and pull out a little bit of the numbers we used here. So these are the offsets. So this guy right here, we'll label it here. This is called fin thickness. This one I did divided by 2 because this offset is the middle. So we go, you have your original surface, your offset, and then your mid. So go ahead and copy this and we'll pull it out. And we'll bring it over here with our parameters. So these ones will come back a little bit later. This is fin thickness. There we go. We'll go ahead and label this, group it, and these are driver surfaces. Okay, so this one down below, there's only one of these. It actually didn't copy because it was the planes we're using to set up our fins. So this is just the series that drives the quantity. Starts at 0. We started them at the 0 point. In this case we did 7, so I can go ahead and hide this, pull it back. Actually, let's leave this for now. It looks like, well, it's got, so when I grabbed it, it was already connected to 2 things, so at some point we're using that again. So let's pull it up, and we'll say, so this series has a couple different things I need to expose here. So one is the number of count, and then this is the distance. Because basically I'm going to plug that into a move. Move is how many planes I'm going to end up with. So I'm going to do this one. This one is the distance between fins. And then we're going to have one more. I'll grab an integer because I'm not going to do a half a fin. This will be fin quantity. Okay, so right now I had 7. I had 10. I'll go ahead and pull that down. And again, I'll hide that so we can keep all our parameters up above. Okay, so let's go ahead and look. These get immediately used for intersections. So I'm going to group that, all these fin planes. Okay. Next step is, if you look at these blocks, they are again a B-rep and plane intersection event. In this case, we're taking the outer surface, the inner surface, midpoint, and we're doing some intersections to solve for that. So one thing that's often helpful is to label some of these things along the way. So you can come back and know a little bit what they are without having to click. So I'm going to go in and add some surface parameters here. And again, this whole process is, a lot of what we were doing the other night was quick. We were exploring. This step that I'm doing now is saying, okay, I've gotten something that's working. Now I'm going to be adding a lot to it. It's probably going to be really helpful if I label this stuff. So you can always do this when you get started, but when you're just figuring something out, it might change, it might shift. Sometimes I take a step when I'm at a good point to do something new, and then come back and kind of do all this labeling work. So in this case, I'm going to call this outer surface, inner surface, and mid. So, and we'll call it outer surface 1, inner surf 1, and mid surf 1. Surf 1 because we'll have the sort of the duplicate of that on the other side. Alright, so one way to quickly re-plug it, looks like everything's just 1, but some of these are a little further out. Yeah, so there's only one of these, so it's pretty easy to reroute. Pull that there, pull that there, pull this guy there. Now these are outside of my my group. Just a reminder, the way to add those is you select the things you want to add. You also select the group, and then you right-click on the group and say Add to Group. Okay. So these next pieces, if we look at them, these were the generation of the fin geometry. So if I look, I have 2 intersection events. They're all bringing in the planes. We can go ahead and do that same labeling to help us later. So I'm going to grab a plane icon here. We'll call this fin planes 1. Here's one of those tricks for rerouting some things quickly. Is you can do the Control Shift, hold them both down, changes your icon tiny bit. And now everything that was pointed to that will follow along and reroute. It also even grabbed the one that was pulling it here, so but I do have one in simple step. So again, I'll select the group and that parameter box and add to group. Okay. All right. Now we'll take a look. So we did these two sections, created the loft between them. Pretty much everything is in a data tree, has been for a little while, all the way back since the intersects. Wait. No, these are all single items. That makes sense. Since this is a list object. So it starts right here. So the intersect command will solve and generate a data tree. In this case, we don't need it. We still have all of them, but it sets it up quite nicely. We'll need this momentarily. Okay. So the loft then generates the fin structure. Alright, so this intersection, so now I'm taking my fins and I'm intersecting, so the fins and the midpoint surface. That'll give me my curve where I'm going to start laying out those pencil lines. So they're going to be starting on the middle of the fin. So if you remember right, what we looked at, this next bit is to start this down a little bit from the very top. When we looked at it closely, they did some typography about the ear along the top, same along the bottom. So in both cases, the pencils didn't start up right at the end. So that's what's going on here. We have our curves. Let's label this guy. So this is bin geometry. Okay, the next bit here, what we did is we took those curves. This is the point on curve, so we did a quick percent down from the top. This isn't a distance, it's just a percentage, 0 to 1, 1 being one end, 0 being the other end. So we just slightly shifted it down. We needed to use the shatter command, which is basically explode, so it'll take a curve and split it into two pieces. So we have our curve, we have our points down a little ways from the end. We wanted to use shatter. Shatter needed a parameter rather than a point. The way to take and convert a point on a curve to a parameter on a curve is curve closest point. It will solve for that number and it spits out what is a parameter. So it's a little bit convoluted here. So you have your curve, point on curve, feed both of those into curve closest point, and it gets you your items you need. And just like the split back here, as a result of two pieces, the shatter has another two items here. If you look in the right there to the data, and in this case we tested it, the 0 item was the top of the curve and the 1 item was the bottom. So we first did this and it was the little short segment. We didn't need that, so I set it to 1. So that's where we ended up with this guy here. So this section we can call, maybe we want to stop this. Might as well stop here. Maybe we'll, doesn't hurt to, you can always regroup things together if it makes sense to add things a little more distinctly. So this one, just to know, was our pencil base curve. And the next steps we did is starting to solve that to make our pencils. So we did a curve divide, got some points, drew a line off that, and then the pipe is basically just like a cylindrical extrusion of a line. So all of those get us to where we are ready to start doing some work on intersections. So let's go ahead and group this really quick. Well, real quick, let's see. So this guy, one number we'll want to pull out is, so I'm gonna grab this is number of pencils. That's this guy here, because it's the divider. So I'm going to do this, and we originally had it set at 50. I'll reset that. We'll do again the trick of hiding it, and I'm going to drag number of pencils back here. So now we'll go ahead and group these guys here. And what's happening here, divide curve, this is just a vector to give it the direction. We know we want to extrude them along the x-axis. I do have no length factor here, it's just a direction reference. The length of the line is assigned here, and it's where we are actually doing kind of double duty. The width here, the distance between fins, and here both applied. But if you come over here and click on distance between fins, you'll see that it is being pulled into both places. So this comes out, and in a little bit of oddball of the data structure, so you have kind of some, we haven't been doing any simplification here. There's been a little bit of large numbers here, haven't been paying attention, everything's been working well. If you look at this, so we simplify after we make our pipes, and I have a double number in the brackets. So that means it's basically keeping, and the n is always 1, so it's got to a branch on the tree for every single pencil. Not the end of the world, but it is a little complex because we don't too much care about every single pencil independently. We care about them kind of grouped together by fin. And if you look at the left side of those double numbers, you have 0 through 9, and that's the 10 fins. So what we really want to do is just get things back into the 0 through 9. Then they'll match more nicely with our fins. If you look at the fin planes, when we finally are solving for those, you can look at it here and do a simplification on it. Data is only one set of numbers inside the bracket, so one branch for each fin, one item for each fin. So you want the data of the pencils to kind of match that. So you still have one branch for each fin, but then the n number will be a larger value of how many pencils are there. So if we look at, come back over here, that's what this guy does. This is phase shift, so it'll shift the data structure over one. Look at the result now. I have 51 pencils in each fin, and that's the kind of data I need to go moving forward so I can start doing intersects with the fins. Alright, so we'll come back to this intersect now. So now we need to sort of duplicate. We'll go ahead and we'll delete this bottom place because we had to repeat a lot of this work. The main difference here is that we started this series over a little bit. We shifted it. So you just have to make that change when we do this. So I'm going to go ahead and delete all this work here. Copy this over now. Copy this bit, which is all the data I want to duplicate. Oh, let me back up. One difference here, we'll leave our mirror. We did that work later. So that's one difference. Alright. So in this case I'm going to copy for sure all of this. So this would be the driver surface, fin planes, fin geometry, base pencil curve. Didn't label this guy, so this is our pencils. Let's do actually one other thing. We'll probably be pulling out fins. So we'll call fin surf 1. And the other thing we'll be wanting is these pencils. So I'll grab a surface block. Oh, and this guy, I laid it on top of the group, but it's not in there, so that happens a lot. You can always tell if you move a group, if something doesn't move, then it's not in the group. So we'll add that. We'll call this one pencil surf 1. Add that to this group. Alright, now I'm ready to duplicate all of this. If you notice, all of these are coming back to this, all these parameters. Looks like that's the only one that didn't get connected further down, but that doesn't matter. And then we also need this loft. I'm going to copy, paste all of that, drag it down. Now the one change is the loft is going to be based on this mirror. Alright. The nice thing is now all of those, because we did that, all of our parameters are being driven up here, so we can change one of these and it will change it for both sides. There's a little bit of difference you'll notice here. So when I started doing this, I noticed that some things were, I'm not getting symmetrical pieces. Alright, so let's go ahead and hide a few things. So we want to hide everything but our fins and our these guys too. Alright, so when I look down these, they were not identical. One side was definitely higher than the other. So they aren't exactly true mirrors. When I dug in a little deeper, the difference is in these offsets. So here's our original loft. First offset goes to the left of the screen. Second line also goes to the left of the screen. I come down here, first offset goes to the left, second one also goes to the left, so but in this case, since it's mirrored, those would actually, you would want them to go to the right. The way you change that is you come over here on this fin thickness, and we want to make this a negative version of it. And so this is where a nice expression is. So what this will do is you can take a number coming in and change it. So right now this is coming from our parameters value up to the left. We're going to just make this negative. You always write x for the value that's coming in. If you wanted to add 1 to this number, you would write x plus 1. If you want to divide it by 2, you would say x divided by 2. In this case, we want the number coming in, regardless of what the name of the input parameter is to be. You just relabel it as x. Alright, so if we come back now and mouse over this, it's -6, -3. If I look at my loft, it's moving them to the right, moving them to the right. Okay, so the other difference is this guy is to start not at 0. If we go back to our preview, right now these are on top of each other, and they need to be offset by 1 value. So, alright, so in order to shift these over, we're going to make sure I got the recorder back. Alright, in order to get rid of that extra set, what we actually need to do is trim off that branch number 9 in this case. It won't always be branch number 9 if we change our number of fins here. We reduce this from 10 to 5. Now we have the same issue, we have 1 extra set. The data is number 4. So in order to make this parametric, in order to make this kind of dynamically adjusting, we have to pull that number out and use it to trim. So in this case, that number corresponds, the number of the branch is 1 less than the fin quantity. Fin quantity starts at 1, counts to 5. The branch numbering, if we go back and look at it, it starts at 0 and moves to 4. So still a total of 5, just 1 offset. So I'm going to go ahead and do a minus here, and I'm going to pull the fin quantity all the way forward. Do a -1. I'll go ahead and hide that again so those parameter lines don't mess up the flow of our data. So now we have our 4. Now there is, under the set command under tree, a split tree. Actually kind of simplified it for us because we want the last one gone. So what you do is it asks for 2 things. It asks the tree to split, which is going to be, shift this over, and then the splitting mask. In this case, the splitting mask is that, oh, I forgot. So it needs this written in the terms of the way the data tree looks. If you look over here, we want to get rid of the branch that's curly bracket 4, close curly bracket. That's the value we actually have to pass in there. And there's another one here for construct path that you can pass a number in, and it gives you that nicely formatted data. You can pull that down, and now we have it. So this is the if you look at this, there's two values coming out. One is the positive set, means the one you selected. We actually selected that end, and what we care about is the everything else. So the negative, and so that is now our 0 through 4. If we reroute this, and we look at it over there, now you can see that the 4 green colors are selected and the last one's not. We hide all these, we won't see that anymore. So we need to grab these 3 things. I forgot to do this before we copied and duplicated this, so we need to do the same work here. But we're just going to take this, subtract this path here, we'll just paste them all down and reroute it down here as well. So now we're going to pull out of this phase shift up to here and the negative into there. There we go. And they're floating here, but they actually need to be added to the group in both cases. There we go. Okay, hopefully we don't have to go back and do any more changes on both sides of our scenario. Okay, so now what we need to start doing is some of these intersections. And some of them are intersections on one half, like the sort of standard holes that we're going to do are actually just from one side to the other. So you're going to intersect fins from side 1 with the pencils from side 1, and then we're also going to solve for the fins from side 2 to the pencils side 2, and then there's one set of intersections that's where they combine, so where the pencils from side 1 intersect the fins from side 2 and vice versa. So we're going to have 4 sets of intersection fins, and actually a little bit more because we're going to have kind of structured data here. And so the way it does it is it doesn't just solve every pencil intersecting into every fin. You can do it that way, but you start to because you're starting to have such large quantities, especially if we run this number right now, we have 5 fins with, say, 50 pencils. Eventually when you have 100 fins, to do intersections from everything to everything will start to really bog down the computer. It'll take sort of minutes at a time, and maybe will not even solve. So we still like that it's doing this structured data comparison. So if I look at these, it's only going to intersect the fin 1 with the pencils adjacent to it, and so it solves it much quicker because that's just a 1 to 50 instead of a 1 to 10,000. So let's do that kind of simple intersection right now. We'll do pencils with fins. So I'm going to go ahead and find fin surf, and this guy that we had before is B-rep to B-rep, which is also surface to surface. This guy was already simplified. I didn't need to do anything. This one I simplified right here. If you look back here, I could also simplify that, but I'll just leave it for now. And if I look at the results, there I have my circles that get carved out of the fin. And it looks like, let me count how many rows of them. 1, 2, 3, 4, 5. In this case, what it's doing So I have 5 fins coming in. I have 3 sets coming in. Let's see what the data is coming out. To do another phase shift to see if it's actually working. Type phase, that's pH. Oh, sorry, shift paths. We do another, these are the intersection curves. We do another -1 shift, which is the default. Okay, so we have our 0 through 4. I think though, nice. Alright, so this is one lucky happenstance of what it does when you have 2 data paths that are different. So if we look here, we have 0, 1, 2, 3. So that's the number of data paths for the tree for how many sets of pencils here. So I have my 4 columns. 0. So this is tree 1, or sorry, tree 0, tree 1, tree 2, tree 3. Our fins, turn those guys on. There's a little bit offset there, but you can see there's 0, 1, 0, 1, 2, 3, 4. So there's an extra 1 in the fins. And what it does is when it combines these, because these are very similar, when it got to the end of the line here, it basically repeated the last set, which is exactly what we want it to do. So it's taking this last set of pencil curves, intersects it on one end, and then it intersects it on the other. We'll see. Hopefully that doesn't cause some problems later, because you can also see we don't have these intersections here. We just have the, a little bit tricky to see all of this at once, but the only pencil that we have on both sides of is the last row. So we're missing all of these ends. So we'll come back to that a little bit later. That's a little bit trickier because we need to do some kind of annoying data manipulation to move that stuff over and get that second intersection event. So the other set of intersections we care about for fin surface 1 is actually what happens when the pencils from the other side hit it. So we'll go ahead and copy this and paste. So this guy coming in was coming in from the fin surf. But let's go ahead and pull the pencil surface. Interestingly, now we're getting zeros. And the reason is because of the offset. So I'll have pencil surf there, and the fin surf there. If you look, what's happening, because this is moved to the left, so it's going to take, this is branch 0 fin, and these are branch 0 pencils. They actually never intersect. The ones that do are branch 1. So branch 0, branch 1. So there's this offset, and so all of these intersections, even though we can see that there should be some holes being drilled for these to cross through, we get 0 intersections because there is never any values. Oh, same issue. When you get down to the very end, it repeats, and then that works because then it's testing both. So that guy didn't work, but if we look at the reverse of that, so let's pull this guy down and do the reverse. Come back to the shifting. So what happens if I do fin surf 2 and pencils 1? This I get a very different, only in my head. Oh, no, we're doing good. It's just there aren't very many solutions. If we highlight these two, pencils 1, bin 0. So these aren't offset. They actually match up, and we're getting probably the right number of solutions here. Yeah. So total number is 9. 9 solutions. So we have nothing on the first fin, which they aren't connected, so that makes sense. And a couple there, a couple there, a couple there. Those numbers look right. So these are some. So this works without any manipulation. So let's go ahead and talk about how we will do that. Same thing here, because we'll have to use that a few times. Now there isn't a very straightforward way, at least that I've found. If anybody else can find it, it would be great. Seems like shift paths would be the great thing to do to renumber it. The only thing I've found is this sort of hack, but it's just a different way of selecting these. So if we look at this, what I need to do is take these fins, and ignore the first one and grab the second ones and third ones, and then intersect them with the these pencils. And you have a choice here. You can either move over the fins, or you can move over the pencils. And what you're really thinking about doing is, when you look at these numbers, is just changing the way that they are combining and intersecting. So what we're going to do here is leave the fins the same. And the reason is because we're going to have all of these piles of circles when we get done. And right now they're all, no matter what we do, the operation, because they're still in data trees, they are all nicely labeled and associated with their right surface. I know that the circles that are in that 0 branch match with the first surface here, so that when I pull it apart later to make a file to cut, I'm not going to be doing any grabbing circles from the wrong one. So I think what I need to do here is grab and compare and intersect the surfaces, leave them numbered the same way we are, and shift the pencils slightly differently. So the way tree branch works is I can take this, so right here we care about these, we're going to shift these guys over, so I'll drag this down. If I just set a path, if I set 0, it's just going to grab the first one and kind of right up the line. 1, 2, 3. And so you can use tree branch to sort of show you the order, what things are, and visualize one branch at a time. And so the issue we need to do here is to basically renumber what those internal structures are. So we have 0, 1, 2, 3, and then we have these fins, 0, 1, 2, 3, 4, and when these intersection events happen, they only will compare in a similar order. So it'll take the first item, tree branch 0, it'll compare it to the first one here. So we need to do a little bit of restructuring of this so that the items are shifted over. We can't even just shift them without kind of just renumbering them, just making 1, 2, 3 to match up. It will still not intersect correctly. I think it should. I'm kind of not sure why it doesn't, but but we'll kind of go through that. We'll need to put a placeholder in the 0. So there is a replace paths, and it works just by basically giving it a set of numbers, sort of the same paths here. In this case we need to give it a series. So I'm going to go ahead and delete this. We're just using this to visualize. And so what we need to do is to build up a series that lets us renumber these guys that we care about, and then we'll go ahead and we'll add one extra placeholder to the end. We'll actually use this one we took out, just because it's hard to replace, put an empty value in there. We know that even if we put that at the very beginning, it won't affect it. It'll just kind of solve for no intersections, and it's just handy. We already have it right there, so we'll go ahead and use it. So I'm going to start with a series. The series is going to, the first one we're going to do is kind of match this number series. We have 0. We need to have the, since we're doing a replace, we need to have the start values, which they call search masks, and then the replace list will be the shifted numbers. So right now we just need to make a 0 through 3 series. So start with 0, step number 1, total number of values. So we kind of have that. It still needs to be dynamic. It's fin quantity. It's just fin quantity minus 1. I'm going to pull this down here. Whoops. What's this? One other. There we go. Okay. Now I'm going to go ahead and hide that. So 1, counting to 5. So that's too many, 0s or 4. So I'm going to do an expression here. Similar to what we did before when we did the negative, we're just going to do x minus 1 here. Now our series should be 0, 1, 2, 3, 4. Or 0, 1, 2, 3. Yep. I'm going to steal this construct path. This path construction will take our numbers, and we'll add the brackets. Right, I don't need it exactly like that, so I'm going to graph this. Simplify that. Let's see what this is. So I need to look at, so what happens if I flatten it on the other end. There we go. Perfect. Okay, so I got, probably need simplify. Yep, so I got a list of bracketed branch-looking numbers that start with 0 and end with 3. So the ones I'm going to replace this with actually look the same. They start with 1 and end at 4. Because 4 is the highest number of our fins. Yep, 0 through 4. Okay, so I'm going to go ahead and just add a 1 to these. That should give me the same thing, just shift it over. So I did a addition, add 1 value. There we go. I copy paste this. The result should be the same. There we go. 1 through 4, 0 through 3. So these are my start and finish values, and then the numbers I want to renumber are the pencils there. So there we go. So it's same, looks exactly the same here, same data. It's just the numbers shifted over. And it seems like we should just be able to pull this up and could use that, but it tested it. It doesn't actually work. So what we're missing is we need to have a placeholder with a 0 value. I said a moment ago you can't just put an empty, at least not very easily, but I do have this handy number we can use really quick. So the one thing about this, so it's just a list, but it is a list with a little bit of baggage. So this was, this is where we split this and removed that last chunk. And so it's actually internally, even though we don't see it here, thinks it's in position 4. So we actually do need to do another replace here. So show you a quick way to see what that value does. So if I graph this, you can see there it's got 4 in the front. So it's internally, even though you don't see anything here in this list, it still thinks it's in the number 4 position. So I'm going to renumber this one. In this case, my source is going to be the fourth, which I have right here. Pull that forward, and we're going to replace it with 0. So again, the number coming out, again, this is like not the most straightforward thing, hard to visualize, exceptionally hard to see with any of the tools they have. Only really see it if you start to, you can see it here, if I graph this, now my number is 0, so that's good. And oddly enough, the way to combine these is just to push them into an empty surface block. So I'm going to actually, so this is just a surface block. I'm going to disconnect it. You could do, well, let's just do that. Let's grab it from the beginning. So surface, and this will be pencil surf to shifted. And I'm going to hold down the shift, get my plus sign, and add these together. Okay, so I have these. They look like the full data set, but if I do that tree branch now, and I look at item 0, it's actually going to be right at the end. So it's just a placeholder. It won't solve for an intersection, but it will let me match up one-to-one as I need to. So go ahead and we're going to be doing, again, we're doing this all up here with fin surface, so I'm going to copy this guy because it's already attached to fin surface. Paste that. And now I'm going to drag up, so we'll move this one out a little bit. Alright, so now I'm solving for no intersections on fin 1, sorry, the 0 path fin, and half of the intersection there. So yeah, this looks about right. Okay, so I can highlight these. Actually, let's highlight the fins. Probably easier to see. There we go. So we'll see if this makes sense. So these are my pencils from one half intersecting the fins from the other, and looks like that's right. I'll show these. Yeah, we just have that first half one. I skip the first one. Yeah, okay. So let's go ahead and group this. We'll label this as shifted pencil surfaces. And we'll copy this all the way up because we need this up above as well. Copy, paste, drag that up. You can see here these. That was that. Here. Here. Alright, starting to get a little messy here, so, but things are looking about right. Again, we said we needed to do a few intersections. Let's go ahead and finish this, these first fins. So we said that they needed to be intersected. One side of the pencil, the other side of the pencil, and then the intersection event. So now we have solved. So let's hide these. Let's see if we can see these. Can't see those, so I'm just going to go ahead and hide the pencils for now. We'll see if we can visualize this right. Hide this half as well, and in addition this half. Okay, so I see that we have our curve straight in the middle. We have those intersections. What we don't have is these other sides. Because they start at the middle on one side and then they hit wherever they will. So I'm going to reuse this shifted data and we'll see if this works. So it'll be very similar to this one. This one's an internal one. So it was fin surf 1, pencil surf 1, copy and paste this, and we'll see if this works. There we go. Alright, we have our shifted data and we have our solution. The only thing we might have a little bit of duplicates is, doesn't look like it. Great. Nice thing is all of this data is combinable. It still has all the same tree structure. So holes in, you can see that actually because you can take all these curves and just join them together in a curve block. And hold down shift, just move them all in. So all those same tree structures are maintained. So we'll call these holes. And if I do set tree branch, should be able to grab kind of one by one, see if they match up. And there we go. Okay, so those are the zeros. There's my one, so I have my partial intersect from the other side, and then I have 2 rows poles there. And I'm assuming they all work. I'll jump all the way to the end. Let's look at 4. Yep. Alright. So, this is thin intersections. Down here, so now let's go ahead and hide these for a moment. So I'm going to hide preview off those guys, preview off fins 1, and we'll reverse it here. We'll turn on fin surface 2. And we'll look here, look at this. So I said those are just those intersections there. So we don't even have any internal ones. So we'll go ahead again, copy these guys. We'll do 2 sets. Now, the way we were doing it, the second was always the fin. So, so this bottom one we'll leave. That was the pencils. So now we just need to grab the internal ones. So I'm going to grab pencil 1. We'll see what this solves. There we go. So those are all the first half. And then we'll do our shifted ones again. So I'm going to take the shifted up to A. There we go. Alright, let's see if that's right. Looks good, except I think I'm missing. That's okay. Turn these on. Nope, that's right. Okay, so the last. Well, that's odd. They seem to be going all the way up to the top. Why is that? Make sure that isn't happening on the other side. So, oh, this one's shorter. So what's the difference here? Ah, I also have a little bit of difference here. Alright, so there's something different between the two sides. So we did find that one set of differences that was the offset. But let's take a look here. See if these match. Those look good. Pretty much the same. Loft, loft. Those are identical. Those are identical. Ah, here we go. So, we had a little bit of difference here. So, in this case, there's two ways to solve it. You can either flip the curve ahead of time so that it would be measuring from the opposite side, or you can shift the value kind of the same distance away from the top on the other side. I'll just go ahead and do that. So, wait. You can always, if something is behaving very slowly, you can lock solver. That will let you move it. So in this case, we're going to move it to 0.96. And then I'll right click, unlock solver, that will solve it. See if my, oh, this should be drastically different. Okay, so it's grabbing the small curves. So there's two items coming out of each of these, n equals 2. So in this case, we also need then to shift it to 0. Alright, so now we should have identical mirrored curves. There we go. Okay. Turn off the preview mode. Yep, that looks better. And we'll take a look here. Also grab this stuff, the holes, and no, I don't need the image. There we go. Copy paste. In this case, we'll disconnect all, and then I'll drag these down again. Again, I'm holding shift so I can group them all. And these are the fit intersections. 2. Okay, so this worked well for our set of 5 bins on either side, but now we can also go back here and should be able to change the bin quantity to 25 and have the same set of solutions. It's a good test always when you're working to make sure you didn't hard code a number somewhere that will break. It's doing a lot more intersections, so it should be taking a little while on yours. I think we were running about 3 seconds to solve. Yeah, that's right there. 3 seconds to solve it for 5, so it should be 15 seconds. Oh, 30 seconds for larger quantity. Turn those on, turn these on. There we go. So the good thing is we're seeing lots of intersection data. little too close there, so to look at what we need to do for that. But in theory, we're sort of on target to be able to produce these. So these are all the holes for this set of fins. So the difference here is that the closer these to kind of come to a straight line, the less offset there is from fin to fin, which then also means that there's less distance from the holes. But we will come and look at that later. So the last thing I'm going to do tonight is just a little bit of that introduction to how to get the colors set up. Just so we can visualize it, and we'll review in the next class how to start to pull this out for fabrication, which is a little bit trickier. There's a couple pieces that a file for the mill will want. Some of those times where we had partial holes or holes overlapping, you'll want to solve so that they're actually really complete circles. The software doesn't like to deal with double arcs, so that will work. Do those two holes. That might actually not work for the reality of it, but these are good questions we could ask the makers. How did they address some of these issues of these interactions? Something I can think of right away is you would actually maybe shift ever so slightly up and down the bay by bay. Maybe they don't always start at the same level. So that would mean maybe giving a set of alternating. So in this data set you had coming in your curves and then points. So maybe you shift this value so that they are moving up and down. So we'll look at that in the next few things, but I think this is that's a good stopping point. It's the moment we have our holes solved, our fins, and all of our pencils. Let me run this out across the whole solution set and see what it looks like. So I'll increase this. So again, if you're going to change a bunch of numbers with a long refresh time, then you can lock solver. So distance between fins I'm going to increase a little bit, 9. Fin quantity set to 50. And we'll let this run. There we go. And it looks like I have a little bit of tweaking to do with my surface, but on the right track. Alright, I'm going to save this final file as ChromaGraph 3. And we will start there on Tuesday this week.